Welcome, I am Carlos Vanarik, and this is another presentation of the Earth Environmental Crisis Problems, Mitigation, and Adaptation. And this particular program is a series of what are updates on the environment, including climate change. So let's look at the first information that I want to present you with is that my small business is Optimum Climate Weather and Environmental Services LLC. I'm Carlos Vanarik. I'm the manager and founder. Business website is this website here, and the Linktree website is this one, where you can find social media sites such as YouTube and Facebook, on which I present these programs on the Earth Environmental Crisis Problems, Mitigation, and Adaptation, as well as a PayPal website link where you can go to that if you would like to contribute to this programming. I'm an atmospheric scientist, climate adaptation, and resilience professional, and this is a program of the Earth Environmental Crisis Problems, Mitigation, and Adaptation, and in particular, this is a series of programs on updates on the global atmospheric greenhouse gases and global temperature and heat content. These are recent updates that I'm providing you with through this programming. The global atmospheric carbon dioxide, global atmospheric methane, nitrous oxide, and sulfur hexafluoride are what we're going to look at. These four important greenhouse gases are the primary drivers of climate change. And what do they drive in terms of climate change? For example, the global temperature and the heat content. The global mean surface temperature is that of this lower atmosphere near the surface of the Earth and of the surface of the ocean, and the global upper 2,000 meter ocean heat content change that we're also going to look at. That's the amount of energy from the surface of the ocean down to about 2,000 meters or 6,000 feet below the surface of the ocean. That's what we're going to look at too. So let's continue with looking at this important update of what's happening with the greenhouse gases such as global atmospheric carbon dioxide and its trends. In November 2023, there was about 420.37 parts per million measured in the atmosphere. November 2024, the global average was 423.64 parts per million. This is last updated February 7th, 2025. And you can see overall from 2020 through 2024, both the red curve and the black curve show that steady increase of atmospheric carbon dioxide, its concentration in the atmosphere. The red curve is with the red dots, each representing the monthly average for each month from January 2020 through November 2024. That shows some ups and downs to it, that red curve. That's because there's an annual cycle in the concentration or amount in parts per million of carbon dioxide in the atmosphere. What happens is that in certain months of the year, there's a little bit more absorbed by natural processes such as vegetation cover over the land surface of the Earth. And that takes out somewhat some of the accumulating carbon dioxide in the atmosphere. But the general trend, as you can see, is upward, even though there's some monthly variations annually in that carbon dioxide concentration in the atmosphere. The black curve with the black dots, that's showing the monthly average with removing that variation during the months of the year on an annual basis, smoothing that out somewhat from January 2020 through November 2024. However, the important point to see is that both curves are showing a steady increase over that several year time period, and that's because the majority of the greenhouse gases, including carbon dioxide, that reach the atmosphere are due to human emissions of those greenhouse gases. That comes from the burning of fossil fuels such as coal, oil, and natural gas, which is the primary source of energy production for sustaining the world's energy needs. Only a small percentage of the energy that's produced is from renewable energy sources such as solar, wind, and other sources such as geothermal power. So because of the majority of energy being produced due to the burning of fossil fuels, the amount of carbon dioxide and methane and other greenhouse gases is steadily increasing in our atmosphere. As you can see, from 1980 through 2024, there's a steady, again, substantial increase in carbon dioxide in the atmosphere. There was about 335 parts per million in 1980 to a concentration of about 423 parts per million towards the end of 2024. So over that 44-year time period, there was about an increase of around 85 parts per million of carbon dioxide concentration, the amount in the atmosphere. That's a substantial increase because if you put it into perspective, between 1850, when the Industrial Revolution started to increase in terms of the use of fossil fuels to produce energy, the increase from 1850 to about 1950, about a 100-year time period, was from 275 to about 305 parts per million or so, about a 30 parts per million increase in 100 years. But as you can see, in only about 85 years, only about 44 years, there's been about a 85 parts per million increase, because we are using, especially after 1950 and especially after 1980, an increasing amount of fossil fuels to meet the growing energy demands of our energy production that was required to sustain our societies. So that's a very important point to look at. Now, the other important thing about is the growth rate of carbon dioxide on an annual basis. That's what this graph shows, this bar graph. So that means that in 1960, there was about a growth of 0.8 parts per million. That means about 0.8 more parts per million accumulation in that particular year in the Earth's atmosphere. If you look at 1988 or so, for another example, that was a growth rate of about 2.6 parts per million. That means 2.6 parts per million more of carbon dioxide accumulated its concentration in the atmosphere. And then if you look at the black horizontal lines, those are showing the decadal annual average over a 10-year time period. So from 1960 to 1969, the 1960s, the average annual growth rate was about 0.8 parts per million. As you can see, over the decades, that's generally been increasing. In the last decade, the full decade we have of is the 2010-2019 10-year time period. The annual average growth rate for that 10-year time period was about 2.4 parts per million. So that indicates the increasing amount of use of fossil fuels that emit greenhouse gases such as carbon dioxide into the atmosphere. That's increased that annual growth rate to about an average annual in the last decade of about 2.4 parts per million. Next, we're going to look at atmospheric methane, the global atmospheric methane, and trends in that atmospheric methane. October 2023, 1,930.61 parts per billion. October 2024, 1,942.94 parts per billion. Methane also increasing in the atmosphere. Since 2020 through 2024, you can see over these last several years, atmospheric methane concentration or amount in the atmosphere has steadily increased. And you can see from 1983 all the way through 2024 a general increase in the global atmospheric methane concentration. And if you look at its growth rate, there's generally a substantial positive growth rate annually in in methane in the atmosphere, except for a few years here in between about 2000 and 2005. And what happens is that although for greenhouse gases, the majority of it comes from the burning of fossil fuels to meet the energy demands of our growing human population, the emissions of those greenhouse gases such as methane into the atmosphere. There is some regulation from natural processes, biological activity, organisms, plants, animals on the land surface and in the ocean itself. And there were several years or a few years here in that 2000-2005 time period in which there was actually more absorbed by those natural processes than could accumulate in the atmosphere. So there was actually a growth rate or negative amount of growth rate, which actually meant it was decreasing the amount into the atmosphere for several years there or so. But generally, again, with methane, just like with carbon dioxide, we see that positive growth rate in the atmosphere on an annual basis. Then when you look at global atmospheric nitrous oxide, in this third greenhouse gas out of the four we're going to look at, October 2023, 336.89 parts per billion. October 2024, 337.91 parts per billion. So it's growing in the atmosphere in just that past year. And again, over the years 2020 to 2024, this is also growing nitrous oxide, this greenhouse gas in the atmosphere. And from 2001 through 2024, growing substantially its concentration or amount in the atmosphere. And the annual global increase, the growth rate for nitrous oxide, also from 2001 to 2024, each year shows a growth rate that's positive. Therefore, more is accumulating in the atmosphere not only annually, but also over many decades. So if you take the annual growth rate, let's say you take an annual growth rate for each year, you get how much the growth rate was on average for 10 years. If you average it out over 10 years, that's what that growth rate, you can look at it that way as well. For any of these greenhouse gases, that's what the annual growth rate can be interpreted as well. Then finally, we're looking at global atmospheric sulfur hexafluoride. October 2023, 11.50 parts per trillion. October 2024, 11.91 parts per trillion. And we look at from 2020 to 2024, increasing substantially sulfur hexafluoride's concentration in the atmosphere. And from 1997 through 2024, also increasing substantially in the atmosphere. Sulfur hexafluoride's annual growth rate substantially positive in each year from 1997 to the last full year that the records are available for through October 2024 at least, up to this amount here of annual growth rate. So there's been an increase in all four greenhouse gases in the atmosphere, not only in the last several years, but also in the last several decades. And what's happening is that that's influencing the global mean temperature, surface temperature of the atmosphere near the Earth's surface, and also the mean temperature of the surface of the ocean. And again, the ocean heat content from the surface of the ocean down to 2,000 meters, or about 6,000 feet below the surface of the ocean, is also increasing. Why is that? Well, greenhouse gases such as carbon dioxide, methane, these four main or important greenhouse gases that are the main drivers of climate change, or important drivers of climate change, what they do is they trap the amount of energy that reaches us from the sun in the lower atmosphere. They slow down the release of that energy back into the atmosphere. So the energy accumulates in the lower atmosphere and in the ocean itself as well. And what that results in is then the temperature of the atmosphere and the ocean increases. And what that then results in is the increasing of certain climate and weather events, the severity of those, the intensity, the duration, the frequency of those events increase because you have more energy measured by the temperature of the atmosphere and ocean, and that results in more increased intensity and frequency and duration of extreme flooding, rainfall events, drought events, heat waves, and also contributing more and more to the melting of the Greenland and Antarctic ice caps and the mountain glaciers in the high mountains of the Andes in South America, the Rocky Mountains in North America, the Alps in Europe, the Himalayas mountain range in Asia. And the melting of those glaciers and the ice caps over Greenland and Antarctica due to increasing temperature of the atmosphere, due to increasing temperature of the ocean, is resulting in more water going into the oceans, therefore contributing more to sea level rise. This is all, as you can see, one factor influences another, and the fundamental driver of these changes in the climate that are increasing in severity and intensity and frequency is the use of fossil fuels, primarily for producing the energy needs of our world society, which emit substantial amounts of greenhouse gases into the atmosphere, which again trap that energy in the lower atmosphere and in the ocean itself as well. And according to the scientific community, climate scientists and atmospheric scientists, including myself, an atmospheric scientist, what needs to be done is, as rapidly as possible, stop that upward trend in the emissions and growth rate on an annual basis and concentration, increasing accumulation of greenhouse gases into the atmosphere by reducing as much as possible in the years and decades to come, down to zero eventually, the emissions of greenhouse gases in the atmosphere by reducing as quickly as possible in the years and decades ahead the use of fossil fuels to produce the energy to sustain our energy needs, and shifting over more and more as rapidly as possible in the years and decades ahead to the use of renewable energy such as solar and wind and geothermal energy. And that needs to be done again as quickly, as rapidly as possible in order to facilitate, to make it as much of an impact on the global mean surface temperature and the heat content of the ocean. Because what we can see what's actually happening due to increase in greenhouse gas concentrations in the atmosphere is the temperature of the Earth, global mean temperature, which is the temperature over the surface of the land, which is actually the lower atmosphere over the surface of the land, averaging that, plus also averaging together with that the surface temperature of the ocean, we get the global mean temperature. And the period of record for this is from 1850 to 2024. And it's from 6 independent measuring systems of thousands to tens of thousands of weather instruments that are distributed around the world. And one is, for example, from the United States NASA system. The other is from the European Union system of observation instruments. The other is from a Japanese system of instruments. We have 6 independent measuring systems. And what's important about independence of measuring systems in science is that if those 6 independent systems are agreeing on their measurements, then you probably have a very credible support for your measurement system, whatever you're trying to measure. If there's a discrepancy or significant difference in the measurements, then you don't have as much credibility to your system of measurements, and you have to go and correct for that, or see why there's a discrepancy. Well, if there's an agreement, then you have a good credibility for your system of measurements. And here these 6 independent systems are generally in agreement. You can see the colors that are used in this graph are the 6 different colors of the 6 different measuring systems, and they're all generally in agreement throughout the 1850 to 2024 time period. Very good agreement, in fact. And what they're used against is the 1850-1900 average. In other words, the 0.0 horizontal line is 0.0 degrees Celsius. That's the 1850-1900 average temperature, a reference for our measurement of the temperature relative to that 1850-1900 average. In other words, for example, in about 1880 was about 0.4 degrees Celsius, about on average, the global average mean temperature versus the 1850-1900 average. In 2024, it was at 1.55 degrees Celsius above that global average of 1850-1900 for the global mean temperature. So that's what we have in this graph, how to read this graph. And then if you look at between 1850 and about 1900, the temperature, global mean temperature, was about, fluctuating slightly above and below that reference of 0.0, the 1850-1900 average, but not much of a fluctuation. There wasn't really an increase in the global mean temperature. After 1920 through about 1940, it increased up to about 0.5 degrees Celsius above that 1850-1900 average. And then what happened is and that was due to the increase in greenhouse gases that were being emitted into the atmosphere due to increased use of fossil fuels as the population and the energy demand of the world increased due to the increasing human population. More and more greenhouse gases were being emitted into the atmosphere. And also, another important factor in emitting greenhouse gases into the atmosphere is agriculture. Agriculture also contributes a substantial amount of greenhouse gases to the atmosphere in order to meet the food supply of our growing human population. So those two factors, agricultural production increasing and fossil fuel use increasing during 1920 to 1940, increased the amount of greenhouse gases in the atmosphere. And therefore the temperature responded to that. Between 1940 and about 1980 was a leveling out of the amount of temperature change. It pretty much leveled off for about those 40 years or so. What happened then is that in those years there was substantially more coal being used to produce energy. And coal, besides emitting greenhouse gases like carbon dioxide into the atmosphere, it also emits another gas called sulfur dioxide. That gas combines in chemical reactions with certain compounds in the atmosphere. Itself, also sulfur dioxide, along with those chemical reactions with other compounds, creates particulates that tend to screen out or reflect a certain amount of the sunlight reaching the Earth's surface and preventing it from reaching as readily and as much the Earth's surface. And so that, even though greenhouse gases were increasing still in their concentration in the atmosphere, fossil fuel production, agricultural production was increasing. There was a dampening out of that effect of the increased greenhouse gases and increasing agriculture. So the concentration was increasing of greenhouse gases in the atmosphere, but the sulfur dioxide helped to dampen the effect on the temperature of that. So what happened was after 1980, coal was used less and less, although fossil fuel production for producing energy continued to increase, but it was more oil and natural gas which produced less sulfur dioxide, and therefore the atmosphere started to accumulate more energy again near the surface of the land surface, in the lower atmosphere, and in the ocean surface, and therefore the temperature responded. The global mean temperature started to go up, and it started to go up to much higher amounts, to finally 2024 being at 1.55 degrees Celsius above that pre-industrial average. And the higher the temperature goes, that's a reflection of there's more energy in the Earth's atmosphere and ocean. And the more energy, again, results in more intensity and frequency and duration of extreme weather and climate events such as flooding, rainfall events, droughts, wildfires, heat waves, and increased sea level rise. So that's concerning that the temperature of the atmosphere has gotten to that 1.55 degrees Celsius above the 1850-1900 average and has increased overall significantly since 1980, or substantially since 1980. What we're going to look at finally is the global upper 2,000 meter ocean heat content change. So again, if you go from the surface of the ocean down to about 2,000 meters, 6,000 feet below the ocean surface, you get the ocean heat content. The average ocean heat content, it's measured in units of zettajoules. The zettajoule is basically a very high amount of energy, a very large amount of energy. And the 1981-2010 average is the zero baseline here of the amount of energy in the ocean. And the record goes from 1955 to the last full year we have a record for is 2024. So if you look back at the year 1955 compared to the 1981-2010 average, which is the zero baseline here, you have that there was about 180 zettajoules less compared to that 1981-2010 average. The amount of energy increased as the amount of energy accumulated more in the ocean due to increased use of fossil fuels, therefore more emissions of greenhouse gases into the atmosphere. The energy accumulated more and more in the ocean, and by the time we got to around 2000, it was about 100 units of zettajoules above that 1981-2010 average. And finally, by 2024, we've reached about 300 of those units above the 1981-2010 average. And overall, from 1955 to 2024, we've gone up about 500 of those units of energy of the heat content, how much is stored in the ocean. And what's important very much about the ocean is that 90% of the energy that accumulates in the atmosphere, in the Earth's system, 90% of it is absorbed by the ocean. Only about 10% is absorbed or accumulates in the atmosphere and in the surface of the ocean. So the ocean acts as a buffer to dampen that temperature rise in the atmosphere and in the surface of the ocean because of its absorbing about 90% of the excess energy that's accumulating in our Earth system. Now, the concern is that recent years of observations and also from scientific studies by climate scientists generally indicates that what's happened in recent years, but especially probably will be happening in the years and decades ahead, is that the ocean will probably start to have less of an ability or capacity to absorb that excess energy accumulating in the Earth's atmosphere and ocean system. And what will happen, therefore, is a probable increase in the amount that's accumulated and absorbed by the atmosphere and the surface of the ocean, which will therefore contribute more to the increased temperature rise of the global mean temperature of the atmosphere and the surface of the ocean up above and beyond 1.55 degrees Celsius in the years and decades ahead. What has to be done, therefore, in order to keep that temperature from going higher and the ocean heat content from going higher is, again, reducing as rapidly as possible to zero the emissions of greenhouse gases in the atmosphere. Therefore, by reducing as quickly as possible the use of fossil fuels such as coal, oil, and gas to produce the energy for the growing energy demand of our world's societies, and therefore, of course, going over to an increased production of energy through renewable energy, solar, wind, geothermal energy, in order to, again, reduce the accumulation of greenhouse gases in the atmosphere and therefore dampen out somewhat the increase in temperature to probably leveling it off if we do that several decades from now, so that it does not go up and beyond 1.55 degrees Celsius that it reached in 2024 by that much at least, and so that the ocean heat content also does not increase furthermore substantially. But right now, as of this past full year 2024 and into 2025, the use of fossil fuels is still the primary majority of the way of producing energy. for our society around the world, for our human population. Renewable energy is still a small percentage, and therefore emissions continue to be very high and increase in terms of emissions of greenhouse gases into the atmosphere, and therefore the concentration or amount of greenhouse gases that's accumulating in the atmosphere continues to increase. So that's very concerning and is important to address. This has been another presentation of important information. These are updates on recent information on the climate system, and there'll be more presentations such as this on the general Earth's environment and also on the climate system. And these presentations are available in both English and Spanish on my different social media websites such as YouTube and Facebook. And I'll be producing more of these updates as well as seminars and other content that is important on the Earth environmental crisis problems mitigation and adaptation coming soon. And if you have some questions about the technical terms I use, such as parts per million, parts per billion, you can look back at some programming that I produced on the Earth environmental crisis problems mitigation and adaptation in the last several years. And I'll be also producing more programming that'll go ahead and review some of that terminology so you can understand it better. Thank you very much for viewing this program, and I'll be producing more very soon.